All right, good morning, chemistry. First off, I want to start out by saying I'm having an issue with my laptop right now where it keeps auto adjusting the brightness while I am trying to move around, which it hasn't ever done before, not this bad. So I have put on a lighter, I'll take this off, that might help too. Put on a lighter hoodie instead of my dark shirt, and hopefully that will help. But if I don't know if you guys can see this, but when I step off screen, it adjusts and becomes significantly darker. But when I come on screen, it gets so bright that I can't hardly see the stuff on the board. So I don't know if that's happening for you guys too. If so, I apologize. I'm going to try and use some bold, dark markers to deal with this. And hopefully I'll get this fixed before I have to post any more videos. So that's what's going on. Just wanted to give you a heads up before we get started. So now I've said that, I'm going to go take care of a couple of things, and then we'll get started. All right, so this is the video for molar mass, and I'm going to be going through and demonstrating how to actually calculate molar mass for different compounds. My expectation is that you will be able to take absolutely any chemical formula for any compound and determine its molar mass, provided you have a periodic table. By the way, you're going to need a periodic table. Okay, so let's start out by talking about what molar mass is. Molar mass is dealing with something called moles, which we'll deal more with later on in the next unit. For now, you need to know that the molar mass is how many grams of a substance it takes to have 1 mole of that substance. Now, the really, really cool thing about molar mass, by cool I mean convenient, is that the molar mass for an element is the same as its average atomic mass. So if we look at hydrogen, hydrogen's molar mass is, good Lord, I can't read that in the reflection here. There we go. 1.00795. So that's the molar mass for an individual hydrogen atom. It would take 1.00795 grams of hydrogen to give you 1 mole of hydrogen. So that's how you determine it for any element on the periodic table. You determine its molar mass by looking up its average atomic mass on the periodic table, and that's the molar mass for that element. Now, for a compound, you add up the molar masses of the individual elements that make up the compound. So, for example, if we were going to do hydrogen gas, which is H2, we would have to take this 1.00795 times 2, because there are 2 atoms of hydrogen in H2. For water, H2O, we would have 2H plus 1O, which is 15.9994. And so adding those 3 up would give us the molar mass of water, 2 hydrogens, 1 oxygen. So this worksheet, worksheet 2, is practice for you at calculating molar mass. But it is also practice at using sig fig rules. So you are going to have to follow the sig fig rules from worksheet 1 while doing these calculations. And I'm going to do 2 on the board, and then you'll be on your own for the rest of them. I think there's 18. There might be 20. It's somewhere in there. So first off, we're going to do a simple one, NaOH, sodium hydroxide. So we need to find sodium, oxygen, and hydrogen on the periodic table. So sodium is here, hydrogen is here, and oxygen is here. So I'm going to list those elements on the board. Okay, can you read that? Yeah, you can read that. Okay. Wow, until it bleaches out. Has it been flickering? I hope it's not. This video might be terrible. Okay, so as I do this, I need to note how many of each of these are present. So if we look at this formula, there are no subscripts at all. So there's one of each. So 1, 1, 1. And then I'm going to say times by each of these. And we're going to write down the molar masses of each individual element next. So I'm going to pause this and do that so that this video can be as short as possible with the lighting issues that I'm having. Okay, so now we have the individual elements. For each one, this is the molar mass. Since we only have one of each, 1 times the molar mass gives us the same thing. Then we just have to add these up. So if we add this up, we'll get 5, 4, 9, 13. You know what? I'm going to pause this and do this because there's no reason for me to add it on screen. Okay, so those 3 numbers add up to 39.99715. Now, at this point, I'm going to pause for a second and point something out. These ones are subscripts. And because they are subscripts, they are integers. Since they are integers, they have an infinite number of sig figs. So these do not affect these 3 numbers. These have to have the same number of sig figs that they had here. So 6, 6, 6, 6, 6, 6. So since all 3 of these have 6 sig figs, our answer should have 6 sig figs. But our current answer has 7 digits. So we have to round it down to 6 significant figures. So to do that, we're going to count 1, 2, 3, 4, 5, 6. This is our last sig fig. So then we round this number based on what follows it. Well, 5 causes 1 to go up. So our answer would be 39.9972 with nothing underlined. Okay, and that is going to have units of grams per mol NaOH. And that went off the board, didn't it? Oh, just barely not. If I write this smaller, it'll fit. NaOH. Now does it fit? It fits. Okay. Units of molar mass are always grams per mole. You have to add the formula to the end. Okay, so that's a simple one. I'm now going to pause this and set up a more complicated one where these are not all ones, because that changes some of your rounding issues over here, if you can see where I'm pointing. But before we add them up, we have to round again. So I'm going to pause this, pull up a different one, and then we'll be good to go. Let it adjust there so you can see it a little better. All right, we're going to do 16, which is 4Al2SO33. Now, here's something you have to keep in mind when you're calculating molar mass. Coefficients don't matter at all. They are completely irrelevant when we're calculating molar mass. So this 4 doesn't exist so far as we are concerned. Coefficients are only important in stoic and in balancing, and we're not doing either right now. So that 4 doesn't exist. This is true for any molar mass. When you're calculating molar mass, ignore the coefficients. They do not matter at all. So, ignoring the coefficient, we have 2 aluminums, 3 sulfurs, and 9 oxygens. So 2, 3, and 9. And then we need to look up the molar mass for each of these, so I will do that off screen, and I will be right back. Okay, so These are the molar masses taken from the periodic table. Note, this has 7 significant figures. Sorry, I can't talk, apparently, either. This has 6 significant figures. This one has 5 significant figures. And this one has 6 significant figures. So after we multiply, this number and this number can only have 6 sig figs, and this one can only have 5. So I will do the math, but I will show you the rounding portion on screen. So I'm going to do this and just put out what the calculator says, and then I'll show you how we actually round it on screen. Okay, so here we see 2 different scenarios that we have to deal with. First off, we have 6 significant figures, but our answer only has 5. We do not want to sacrifice a sig fig for this calculation. So what we're going to do is we're going to add a 0 to the end of this after the decimal point, because that will bring our sig fig count back up to 6. You can only add to bring your sig fig count back to where it should be. Okay, so if you add 2 3-digit numbers and you get a 2-digit number, then you can add a 0 to the end, so long as it doesn't actually change the number. So it has to be after the decimal point. Okay, then on this one, we need 5, but we have 6. So I'm going to switch colors here. Our 5th digit is this one. The 5 makes the 9 go up. So this becomes a 0. This becomes a 0. This becomes a 2. So this is now, and this goes away. So 96.0200. And then this one has 6, but this has 7. So we have to do the same thing again. This is our 6th digit. So we need to round this one. 6 is going to make this become 5. And then the 6 goes away. And so from there, we just add them up like normal. So I will do that real quick. I would encourage you to do this while I am. Or pause this while I am. Okay, so we've got the same issue again. We had a 6-digit, a 5-digit, and a 6-digit. So our answer can only have 5 digits. So the 5th digit is this one. So the 8 makes this become a 6. So we have 294.16 grams per mole of Al2SO33. So this would be the answer. Now, some of you may have realized that you can't actually enter subscripts in here. So what I want you guys to do is I want you to go ahead and enter this piece into the Google form. Don't worry about re-entering the formula. When we start doing things later, you'll see why it's very important that you do that, and you'll have to write some out and take pictures later. But for now, that should be enough for you guys to get started. Your answers for these all go in the Google form. So make sure you're entering your answer. You have 2 days to work on this. So you get today is Wednesday, after you do the sig figs worksheet, which I give you all of the answers for that. So after you watch that, then you're going to come, you watch this video, which you've already done all that, so I don't know why I'm reiterating it. You have today and tomorrow to work on these calculations. So you'll have Wednesday and Thursday. Thursday night, I'm going to lock this, and you're not going to be able to edit it anymore. But this is a worksheet, not a quiz. So you can do some of it and then go to the bottom and hit submit to save your work. But you have to save it. Okay, if you don't actually save it, if you don't hit submit, it's not going to save anything that you've done. You should be working this out on another sheet of paper. Okay, working this out, getting this process down, is where all of your partial credit comes from. If this number is wrong and you have no partial credit, you get no points. So you need to learn how to get pictures uploaded if you don't know how to do that yet. Friday, we are not going to have a quiz over this. Your quiz over this will be on Monday or Tuesday next week. I don't remember exactly which. Friday, we will start doing naming rules. So that's kind of a rough outline for the rest of this week. On Friday, I will upload a video for covalent naming. You have today to work on this, today and tomorrow. Get this done. I will lock this worksheet at midnight on Thursday evening. So Friday morning, you won't be able to do any work on this. So make sure you get it done. Have a wonderful night, a wonderful couple of days. I hope you guys are enjoying the downtime that I'm guessing you had yesterday and possibly the rest of this week. Look forward to seeing you guys back whenever we get out of yellow. So that's it for this video.